I'm gonna solve a magnetic field problem. The problem says the figure shows a cross-section of a cathode ray tube. An electron in the tube initially moves horizontally in the plane of the cross-section at a speed of 2 times 10 to the 7th meters per second. The electron is deflected upward by a magnetic field that has field strength of 6 times 10 to the negative 4 teslas. A asks, what is the direction of the magnetic field? In order to find the magnetic field, we can use the right hand rule. Alright, so we point our index finger towards the direction that the electron is moving, and the force is up and the magnetic field is down. But since it's an electron, the field is opposite of the right hand rule, so the field would come out of the page. B asks, determine the magnitude of the magnetic force acting on the electron. For this problem, we will use FB equals QVB times sine theta, and sine theta would just be 1. So we know that Q, the charge of an electron, is 1.602 times 10 to the negative 19th. We also know that the speed is given the problem, which is 2 times 10 to the 7th meters per second. Lastly, the field strength, which is given in the problem, is 6 times 10 to the negative 4th teslas. We just plug all these numbers into the problem. And we get FB to be 1.92 times 10 to the negative 15th newtons. For C, it says determine the radius of curvature of the path followed by the electron while it is in the magnetic field. We know that the force of the magnetic field equals the centripetal force, because when it follows a curved pattern, it's due to the centripetal force. So we know that FB is 1.92 times 10 to the negative 15th, which we solved earlier in B. And we know that FC is mv squared over radius. If we rearrange the problem, we get radius equals mv squared over 1.92 times 10 to the negative 15th. We then plug in mass, which we know of an electron is 9.11 times 10 to the negative 31st, and we plug in speed, which is 2 times 10 to the 7th. And then we get radius to be 0.19 meters. For D, it says an electric field is later established in the same region as the magnetic field, such that the electron now passes through the magnetic and electric fields without deflection. D says determine the magnitude of the electric field. Well, in order to do that, we know that we must use the force of electron, which is equal to the force of the magnetic field. Force in an electron equals QE. So we know that the magnetic field equals QE. So in order to find the electric field, we can rearrange the problem to get FB over Q equals the electric field. And that is, we use the numbers we found in B, which is 1.92 times 10 to the negative 15 over 1.602 times 10 to the negative 19th to get 12,000 newtons over coulombs. For the last problem, it says, what is direction of the electric field? Since the force of the magnetic field is upwards, in order to oppose the magnetic field, the force of electric field must be downward. So the electric field has to be upwards.